Alright, we're going to talk about natural exponential functions, and in the other video you're going to talk about logarithmic functions, the natural log. And so the inverse of e to the x is ln of x. That means we're switching our x and y coordinates. And as you notice, I gave you an function. So if you notice, our two biggies to know are 0, 1, and 1, e. Okay, you're going to need to know those for both the e to the x and ln of x. E to the x is continuous and is always increasing, and it's always above the x-axis. So the limit as e to x goes to negative infinity, as we're going this way, we're getting closer to 0. As we get to as x is going to positive infinity, we're going to up to positive infinity. Exponential functions grow faster than polynomials or log functions. And the most important part that you need to know is how to take the derivative. And so the way the derivative works is the derivative of e to any function, e to the x, e to f of x, is you're going to repeat, you're going to write e to whatever your function is, and then multiply it by the derivative of the exponent. So let's hop in. Number 1, part A. So find the derivative of the following. Y equals e to the 2x minus 1. And again, the pattern for when you have e is when you take your derivative, y prime, you're going to rewrite your function. So e to the whatever, 2x minus 1. So this is the original function, and you're going to multiply it by the derivative of your exponent. Well, the derivative of my exponent is just going to be 2. Part B, f of x is equal to e to the negative 3 divided by x. Well, I have a little bit of a complicated exponent, and so I'm going to fix this first. And so I have e to the negative 3, and then I'm going to move my x to the numerator, but when I move it up, it's going to be x to the negative 1. So I have a power to a power to a power. Alright, so now we're ready to take our derivative. And again, the derivative of an e function is you rewrite the function. And next you're going to take the derivative of your exponent. Well, the derivative of negative 3x to the negative 1 is going to be 3x to the negative 2. C, if f of x is equal to e to the 2x, and that whole quantity is divided by 2x, then find f prime of x. So once again, if you notice, I'm dividing, so I have the quotient rule. Here's my high, here's my low, but I have an e function, so again, I have to rewrite my function, eventually take the derivative of my exponent. So my derivative is going to be equal to low times the derivative of my high. And so again, I'm going to rewrite my function e to the 2x. But I need to multiply it by the derivative of my exponent. So derivative of my exponent is 2 minus my high times the derivative of my low. And that whole thing, and that's all over my low. And for right now, we'll just leave it like that. Number 2, if f of x is equal to e to the x, which the following is equivalent to f prime of e. And I hope you notice that I am plugging in e into x. So I'm saying x is equal to e. And so I just want to identify which definition of derivative shows that I'm plugging in x in for e. My function again is f of x is equal to e to the x. And so if I'm plugging in e into x, it should be f of e is equal to e to the e. So which one of these show that type of representation? Well, if I look at A, e to the x plus h isn't showing me that I'm plugging in e in for x. It shows for over here when you have e to the e, but I shouldn't have an x there. I'm plugging in e in for x, so it can't be A. B, e to the h actually shows that I'm plugging in e for x, but if you notice, I don't have an exponent over here with e. It got deleted, so it can't be B. C, e to the x is my function, and you'll notice I am plugging in e in for x. So I have e to the x plus h, in this case e to the e plus h. And then I have finally my parent function, e to the x, but I'm plugging in e. So that's where that f of e is finally coming in. So our answer is C. Number 3, we're going to be using our calculator. Let f of x be a function given by f of x is equal to 3 e to the 2x. Let g be a function given by g of x is equal to 6x to the third. At what values of x do the graphs of f and g have parallel tangent lines? When we're talking about parallel tangent lines, we're talking about where our derivatives have the same slope. So if I did that graphically, it's going to be where my derivatives are going to intersect. So we're going to use our calculator mostly. So I want you to go to y equals, and I want you to plug in 3e to the 2x. Into y1, and then plug in 6x to the third into y2. And I'm going to graph my derivatives, and so I don't want to graph my parent functions, so I'm going to not highlight those. And the way you do that is you go to the equals button and you unselect them. So now we're going to graph our derivatives. So go to Math 8, and I'm going to go to Variables, Y variables. We're talking about functions, and I'm going to graph y1, and I'm going to do comma x because that's my independent variable, comma, and so at this point you've been typically, whoops, lost my calculator. There we go. At this point, you've been mostly graphing with an x equals an x coordinate. Well, I want to graph all values of x, so I'm going to click x. That'll graph all values of x of my derivative. And I'm going to do the same thing with my y2. So I'm going to go to Math 8. So you can just hit 8. And then I'm going to go Variables, Y variables, Function, y2, and then comma x again. And I'm going to graph. And if you had it, typically I'm guessing most of you guys had, I zoomed in, typically most of you guys are going to see this when it's kind of hard to see. So I'm going to change the window. So I'm changing it to -5, 5, and that's what you originally saw. Where it's zoomed in, you can see a little bit better. And if you notice, there's an intersection happening in quadrant 2. So we're going to go to second trace or second calc. We're going to go hit 5 for intersection. And so they're asking, is it y3? Is that my first curve? Sure. Y4, is that my second curve? Sure. And so I want you to estimate. And my intersection, as you can see, is -0.3906. And so what I can do is come over here and just write. We know that parallel slope, so we want to say f prime of x has to be equal to g prime of x. Okay, typically on the AP exam they might give you that might be a point, so make sure you say that. And then you can say where x is equal to -0.390, or you could have written -0.391 if you wanted to round.